Okay, so this is the last question that I saw in Google Classroom, so let's finish it off here. This question is actually from the assignment that you guys are supposed to do. The concentration C of X of a particular drug is of a particular drug in one patient's bloodstream is roughly modeled by that equation over T hours. So keep in mind that T is the number of hours, and C of T is measured in milligrams. So when we give our final therefore statement, we want to be talking about milligrams. What is the equation of the horizontal or oblique asymptote? Let's take a look right now. I know that already it's not going to be an oblique asymptote because the lower degree is on top. There's degree 1 on top and degree 2 on the bottom. It's going to be a horizontal asymptote at y equals 0, absolutely, because the degree is on the top is smaller. So what is the equation of the horizontal or oblique asymptote in this function? Okay, well, let's just answer that then. The equation, you know what? Sorry for wasting your time here, but the equation is, it's good enough. The equation is y equals 0. Boom, done. Alright, what does this mean about what happens to the concentration of the drug in the patient's bloodstream over time? Well, it means it approaches 0 because it approaches the asymptote. I'm going to go ahead and assume that it approaches from the top. Let's do our little division here. So actually, let's just plug in the easiest way to do it right now is just to plug in a big number for t and see if it's positive or negative. So if I plug in 1,000,000, 6 times 1,000,000 is positive. 1,000,000 squared plus 1 is positive. You get positive over positive. Yep, so it is a little bit more than 0. Alright, let's do part B. At approximately what time, so it approaches 0. In other words, I guess, you know what, that's not a very good answer for our context. It says the patient's bloodstream over time. It approaches 0. This means it will always stay in the bloodstream a minute amount, but pretty much it will go down to 0. Almost 0. Okay, so it'll get down so minute that it might as well be 0. If that equation actually models it. I have a feeling that in reality it probably can get to 0 at some point, but who knows? I don't know anything about medicine. So at approximately what time does the patient's bloodstream have the maximum concentration of drug? What is that concentration? Again, we're not in calculus, so we don't really know how to find maximums, but we can kind of do a table of values or a graph. Let's start off with the graph. I know that we have no asymptotes because t squared plus 1 will never equal 0. T squared would have to be -1, and you can't square a number to get -1. So no asymptotes. We do have a 0 at 0. Alright, so let's see what happens here. We already know that we don't have any asymptotes. We do know, we'll call this T, and what was it, C of T? C of T. We know we have a 0 right here. No asymptotes, but we do know that it follows. It's just above y equals 0 off to infinity. So it must come up and go through here. And let's plug a negative big number in here just to see what happens on the other side. If I plug in negative 100 for t, I'm going to get negative 600, so a negative number on the top, but on the bottom it squares, so I'll get a positive. A negative divided by a positive is a negative, so this is going to be, as it goes off to infinity, it's going to be a negative really small number, so it will have, flip that way. Alright, and it's asking us for the maximum, I believe. At approximately what time does this patient's bloodstream have the maximum concentration? So we have to kind of find out, when is that going to happen? What are these numbers here? Well, I guess let's do a table of values. So let's see at x is, so t, and we got c of t. At 0, we got 0. At 1, let me put the equation in front of us here. Let me try that one more time. That wasn't very smart of me. Copy. Alright. So we've got t is 1, we're going to have 6 divided by 2, so 3. When t is 2, we got 12 divided by 4, 5. 12 divided by 5. That's like 2.4. At 3, we're going to have 18 divided by 10. That's not even 2, that's 1 point something. It looks like this is about where we're going to have the most. Okay, I don't know how accurate it wants us to do. At approximately what time does the patient's bloodstream? Okay, t is in hours. I would say it's about 1 hour, after about 1 hour. Therefore, after about 1 hour, the concentration will probably be highest. Alright, I guess I shouldn't be lazy. I guess I should check some numbers right next to that. So let's try 0.9. 6 times 0.9 over 0.9 squared, so 0.81 plus 1 is going to be equal to 5.4 divided by 1.81. Yeah, I think it's time to use my calculator. 5.4 divided by 1.81. 2.983. It's a little bit less. Okay, let's try 1.1. 6.6, 6 times 1.1. 1.1 squared is 1.21 plus 1, so 2.21. 6.6 divided by 2.21 equals 2.986. Alright, that's pretty convincing that 3 is going to be the highest right here. So I feel good about our answer. What else we got? We have a part C here. Part C, what is the domain of this function given its real life context? Okay, well the domain, let's see, it's measured in milligrams. It's a particular drug in the patient's bloodstream is roughly modeled by that over t hours. So I guess you're not going to say you're not going to have like a negative amount in your bloodstream before you take it. No, you start off at 0. So the true graph would actually be like this. okay, but that doesn't follow the equation. So I would say that the domain, you have to be at least at 0. As a matter of fact, it has to be greater than 0, because right when you take it, I think you would have something in your, well, maybe it's not right in your bloodstream by the way, so 0 is fine. And all the way to infinity, really, I'm going to be the type of person who thinks that we can live forever. Eventually we're going to find some way to live forever. If you think we're only going to live to 100, then you have to say, I don't know how many hours are in 100 years, and you would have to say that that's the end of the domain. But I'm going to go ahead and say that the domain is such that, is t such that t is greater than 0. And I'm going to say, and t belongs to R. I don't write that. If t belongs to R, don't bother writing it. We just kind of assume that t belongs to the real set of numbers. So what is the domain of this function given its real life context? Yeah. It's going to keep getting smaller and smaller as long as you live, and I'm going to live forever. All right, there you have it. What a great conclusion for today.